A very good day I wish to my panels. My name is Vaseetha Ravichandran, a postgraduate student of Master of Science in Applied Physics at University of Malaya. Would like to present my research project entitled The Development and Analysis of Electrolyte Material for Dye-Sensitized Solar Cell. So, without further ado, let's get started. As a brief introduction, dye-sensitized solar cells, are also known as DSSCs, which are a subset of third-generation solar cells, have been the focus of intensive research for more than 20 years due to its extraordinary advantages. For example, straightforward manufacturing process, low cost, and environmental friendliness. Fortunately, the sun gives the world a lot of energy, which is roughly 1.25 times 10 to the power of 24 cal annually, or a few thousand times more than what the Earth now consumes. Hence, the IEA has stated that limiting global warming to 1.5 degrees Celsius is possible if we reach net zero emissions. So, to reach this goal, using solar energy is a key solution, and among solar technologies, DSSCs have gained attention because of their ability to perform well even under low light conditions. Moving on to the next part of my presentation, this research aims to increase the sustainability of polymer electrolytes used in dye-sensitized solar cells, or also known as DSSCs, by developing a gel polymer electrolyte using chitosan, acetic acid, potassium iodide, and iodine. So the objectives of this research are, first, to evaluate the fundamental properties of gel polymer electrolyte using analytical characterization, and second, to examine the performance properties of the dye-sensitized solar cell fabricated using the developed gel polymer electrolyte. In this slide, I'm going to be talking about the problem statement of my research project. Firstly, the electrolytes used in DSSCs have a substantial impact on their photovoltaic performance. However, using liquid electrolytes has several drawbacks, including leaking from the cell assembly, poor electrochemical stability, a larger storage requirement, and inadequate thermal stability. Although solid polymer electrolytes and low volatility liquid electrolytes avoid the stability and sustainability difficulties, gel polymer electrolytes with strong ionic conductivity and long-lasting stability are driving replacements for liquid electrolytes in DSSC. In addition, the natural biopolymer has been utilized for the polymer to increase the sustainability of the electrolyte material in order to investigate one that is entirely green, environmentally friendly, and meets the Sustainable Development Goal 7, which is access to affordable and clean energy. The next part of my presentation will be on the methodology of my research project. As can be seen in this slide, I started off with solvent preparation where I diluted 1% of acetic acid into 100 ml of distilled water. Next, I prepared 2% of chitosan acetate solution where I mixed chitosan powder in 50 ml of acetic acid solution. Then, separately and simultaneously, I prepared the salt and redox solution where potassium iodide and iodine has been dissolved in acetic acid solution with the ratio of 10:1. After that, I mixed both prepared solutions which together to form a gel polymer electrolyte. This gel polymer electrolyte was prepared with variation of salt content, which is potassium iodide, from 10 weight ratio to 70 weight ratio percentage. Lastly, the samples were tested for the ionic conductivity, temperature dependent ionic conductivity, efficiency testing using electrochemical impedance spectroscopy, and XID analysis. I have also included the important equation used to find out the desired result, such as the equation to find out ionic conductivity, fill factor, and the efficiency. Other than that, a detailed literature review has also been done in my research project to understand more on the motive of my research project. In this slide, I have included several literature reviews that I have done. According to Coil et al. 2019, photovoltaic cells using dye-sensitized photovoltaic technology from the future have niche uses in energy-efficient interior design for buildings and solar-powered windows due to their inherent accessibility and high solar output in conditions of ambient light. Besides that, Shalini et al. 2015 stated that synthetic dyes are more effective and durable when used as a sensitizer in DSSE, but they have several drawbacks including increased cost and the use of hazardous ingredients. Jimenez Gomez et al. 2020 stated that natural biopolymers are those that originate from the cells of living organisms such as plants, animals, or even bacteria. These natural occurring biomass-derived polymers are primarily composed of a few distinct repeating chemical building units that contain carbon. Praveen et al. 2020 stated that earlier research shows that chitosan can be used as the polymer for the electrolyte because it has piezoelectric properties, making it a good electrolyte for activating the phototropic effect and enhancing the power conversion efficiency in solar cells. Lastly, Kim et al. 2017 stated that studies on clean and renewable energy such as wind, hydropower, and solar energy are continually making progress as air pollution brought on using fossil fuels and the demand for energy rises. Now let's move on to the result and discussion of my research project. This graph shows the ionic conductivity versus potassium iodide weight ratio percentage. Now based on the figure, it can be said that as the amount of potassium iodide which acts as the salt in the gel polymer electrolyte increases, the ionic conductivity also increases until 60 weight ratio percentage of potassium iodide. The ionic conductivity at 60 weight ratio percentage of potassium iodide is 9.99 times 10 to the power of -2 Siemens per centimeter. However, the ionic conductivity at 70 weight ratio percentage of potassium iodide decreased tremendously with a value of 2.97 times 10 to the power of -2 Siemens per centimeter. This is because high salt content in gel polymer electrolyte cause the mobility of ions to be reduced due to the increase in viscosity of the electrolyte, which makes it more difficult for ions to move and conduct electricity. Additionally, high salt concentrations can lead to ion pairing and aggregation, which also reduces ionic conductivity. The next graph shows the temperature-dependent ionic conductivity versus the potassium iodide weight ratio percentage. Now, based on this figure, it can be concluded that for all samples, the ionic conductivity rises along with the temperature. This is because at higher temperatures, the solubility of potassium iodide in the electrolyte increases as well, providing more ions available to conduct electricity. In addition, the thermal energy also increases the kinetic energy of ions, resulting in faster ionic movement and enhanced ionic conductivity. Increased cation mobility increases the possibility of ion hopping, which ultimately lowers the activation energy of ions. The next graph shows the JV curve for the chitosan-based gel polymer electrolyte. The result shows that sample with 60 weight ratio percentage of potassium iodide in the chitosan-based gel polymer electrolyte exhibits the highest current density, which is 3.88 mA per centimeter square, with highest open circuit voltage of 0.51 volt compared to the other samples. This means that the sample has high light to current conversion efficiency, where the sample can effectively convert light energy into electrical current. This table shows the values obtained from the JV curve of DSSE. The fill factor of the 60 weight ratio percentage of potassium iodide sample is about 0.60, while the efficiency is 1.19%, which is the highest among the other samples. Due to diminishing charge accumulation when the JV curves take on a more rectangular shape in comparison to the other samples, the fill factor of the Ki increases from 0.48 to 0.60, which is the potassium iodide. However, the efficiency and the fill factor drop when more potassium iodide is added because the gel polymer electrolyte became oversaturated. When the gel polymer electrolyte is oversaturated with potassium iodide, the concentration of ions becomes so high that they begin to interact with each other in ways that impede their mobility. The interaction between ions can lead to the formation of ion pairs or ion clusters, which are less mobile than individual ions and can decrease the overall ionic conductivity and the efficiency of DSSE. Additionally, high salt concentrations can also lead to the formation of a second phase like a precipitate, which can act as barriers to ion transport. The next analysis will be on the coil impedance plot for gel polymer electrolyte samples with varying potassium iodide concentration at room temperature. Based on the figure, sample with 60 weight ratio percentage exhibit the lowest impedance compared to the others. That means low impedance in a solar cell is generally an indication of good efficiency. A low impedance value in a solar cell means that there is minimal resistance to the flow of electric current, allowing for maximum energy transfer and conversion. This leads to improved power output and overall performance of the solar cell. Hence, it has the highest charge transport at both interface counter electrode or electrolyte and photoanode or electrolyte interfaces of the DSSE cell. Lastly is the XID analysis. Based on the figure, it can be observed that a peak around 10 theta over amorphous hump irrespective of different concentration of potassium iodide. This typical pattern indicated that amorphous nature of gel polymer electrolyte. However, at 70 weight ratio percentage of potassium iodide, a new peak can be seen at around 25.23 theta. This is because as the salt content increases, the peaks become more intense and better defined, indicating an increase in the degree of crystallinity. New peaks may appear in the XID pattern, which can indicate the formation of a second phase like a precipitate. This new peak is caused by the interactions between ions that impede their mobility and the formation of ion pairs or ion clusters, which can lead to a decrease in the overall ionic conductivity. Last but not least is the conclusion. In summary, it can be said that the ionic conductivity and the efficiency of chitosan-based gel polymer electrolyte increase with the increasing of potassium iodide content until it reaches saturated point before going down, and their solar cell characteristics are highly influenced by the presence of the salt content. The results showed that salt content in the gel polymer electrolyte has a significant impact on the solar cell characteristics. With that, I would like to end my presentation. Thank you so much for listening.